Hey guys, so let's have a look at this question. So in this question you have three capacitors of capacitance 5 microfarad, 2 microfarad and 2 microfarad, and they're charged to 20 volt, 30 volt and 10 volt respectively, right? So I've drawn that diagram, I've drawn a similar diagram over here. You have a battery of EMF 11, so you have these three capacitors. They have been charged to 20 volt, 30 volt and 10 volt, so the charge they'll be having is 100, 60 and 20 respectively with the polarities, and they're connected in the circuit with the polarities as shown. So positive plate, negative plate, positive plate, negative plate, negative, positive plate. Okay, so we need to calculate what will be the amount of charge flowing through the battery after closing the switches. So I've already drawn this diagram over here. So after closing the switches, we need to calculate how much amount of charge will be flowing over here, right? Okay, so let's assume that X amount of charge flows to the battery. So the battery, let's say, gives X amount of charge. So X amount of charge will go over here. So this plate will now have a charge of 100 plus X. So the negative plate will have minus of 100 plus X, which means it will push X charge away. So the charge on this plate will become 60 plus X. The charge on the negative plate will become minus of 60 plus X, which means it's pushing X charge away. And now charge on this is minus 20, to which you have X charge being added, right? So the charge on this negative plate will now become minus 20 plus X, which is nothing but minus of 20 minus X. So the charge on the positive plate then will become 20 minus X, and then you have X charge again coming out from this, right? So let's say this is the amount of charge flow which has happened, and we have finally reached the electrostatic condition, as in these are the final charges you have on all the capacitors, right? And now we'll be writing a simple loop law equation to solve this. So let me start from this point and go across the circuit in a loop. So when I go across the circuit in a loop, sum of all potential differences has to be equal to 0. So let me write that equation. So when I go from here to here, potential, we are going across a battery, so potential will increase by 11 volts. So let me write this as plus 11. Then when I'm going from here to here, I'm going across a capacitor, and I'm going from positive plate to negative plate, so potential decreases. It decreases by Q by C, so 100 plus X divided by 5. Then again I'm going from here to here, so I'm going across the next capacitor, capacitor C2. Again I'm going from positive to negative plate, so potential will decrease by 60 plus X by 2. Finally I'm going from here to here, no change. Then I'm going from here to here, and again I'm going across the capacitor, but according to my assumption I'm going from negative plate to positive plate. So because I'm going from negative plate to positive plate, potential will increase, and potential increases by 20 minus X by 2, right? And now I've reached my starting point. So basically the sum of all potential differences has to be equal to 0, right? So this is the final equation I'm writing right now, and as you can notice, there's only one unknown. This is the equation, which is X. So you can find out X value from this equation. So what will that X value turn out to be? Your X value here then turns out to be, after solving this equation, taking the LCM, so that is 10, I'll get 110 minus 200 plus 2x minus 300 plus 5x plus 100 minus 5x is equal to 0. So I'll get 110 minus 200 is minus 90, minus 390, then minus 290. So we'll get minus 290, minus 2x, minus 5x is minus 7x, minus 12x. So we'll get minus 290 minus 12x is equal to 0, which implies 12x is equal to minus 290. So I'll get x to be equal to minus 290 by 12. Right, so this should be your answer for this question. So hopefully this question makes sense. See you guys in the next question.